Alright, in the previous video, we find an by using calculator, okay? And then this is what we have based on the pattern of n, okay? An is 0 if n is even, and an is negative 4 over n squared pi square if n is odd, okay? So, if you don't like using your calculator, actually you can perform this integral by using tabular method, okay, or integration by parts. So in tabular method, you have to provide 3 columns, which are sign, differentiation, and integration column. For sign column, we start from plus, then followed by minus, plus, minus. So the sign is alternating, okay, plus, minus, plus, minus. For differentiation column, we just pick from the function the function that we want to differentiate, or we always use polynomials, so we choose t to differentiate, and the differentiation of t equal to 1, and if we differentiate 1, we get 0. After we get 0, we put a stop, that is the last row. And then for integration part, we need to take the other function, which is here, cos n pi t over 2. And then when we integrate here, we get 2 over n pi as the coefficient. So that is why in the previous method where we apply calculator, we have to take out pi, okay? So we have to take out pi in the calculation so that we get a nice number, okay? And then if you integrate again, okay, so you get this, okay? Now look, we have 1 over pi square as the coefficient. That is the big reason why in the calculator we have to multiply by pi square, okay? So back to the tabular method. Next, you collect the answer and you perform this integration. This is a long story. You have to integrate one by one and put the integral limits, and then you will get this format, okay? After you get this format, again you have to look at the pattern for n odd and for n even. Similarly, we will get the answer as in your calculator, okay? 0 if n is even, odd if n is odd, so n this value, okay? So you have you can choose whether to use your calculator or you want to use the theory of integration. Okay, now we move to Bn. To find Bn, we just plug in the formula 2 over t integral of this. Okay, remember, you have to substitute the value of period, capital T, and also omega. So here we take note omega is pi over 2 and t is 4. We plug in into the function. And then for integral limit, we take for one cycle, 0 to 4. After that, we separate the integral, okay, 0 to 2, 2 to 4. And then for each t, it corresponds to the interval that we are dealing with. For 0 to 2, ft is t, and for the other part is 2, okay? So again, when you look at this integral, there are 2 times that t appears, so you have to use tabular method or integration by parts, okay? And this one, the other part can be integrated manually, okay? So we can also use calculator. So in the calculator, you have to do like this, prepare a table like this. First put n column, and then a represent the first integral, b represent the second integral, and we want to add a plus b, and then we want to get 1 over 2 of this, okay? So lastly we want to get this, okay? So here again, when you put the integral into your calculator, you will get a decimal points, which cannot be converted into fraction. So we know that there must be a coefficient 1 over pi or 1 over pi square. It depends. So you have to try, okay? If we can multiply by pi and get a nice number, then this is our conclusion. If not, you can try to multiply by pi square. So that is the trick, okay? And we found that for a, we just need to multiply by pi to get a nice number. So means that in your solution, you should multiply by 1 over pi, okay? So now you can list down all the values for a, and then do the same for b part, okay? For b part, you need to multiply by pi again to get a nice number like this. And then you have to add a plus b, so this column plus this column, and then you have to divide by 2. So the last column is the bn, okay? We want that bn is this. So look at the pattern here, okay? First you can separate between odd and even number. First let's focus on 2 and 4 value. When 2 you get 1 over pi, and 4 1 over 2 pi. So what is the same thing here? It's just negative 1 over pi for both. But for the difference is we have 2 here and we have 1 here, right? So what is the formula? So when n2 we get 1, when n4 we get 2. So means that this is n over 2. So this is your formula, negative 1 over n over 2 pi, and when we arrange, we can put the numbers negative 2 on the upper part, and then this is what we have if n is even. And then look at the pattern for odd, okay, which is n1, 3, and 5. So every odd number will have this format, negative 2 over pi, negative 2 over pi, negative 2 over pi. And the difference only occur at the value here. When n is 5, we get 5. When n is 3, we have 3. And if n1, we have 1. So means that the formula for that is just negative 2 over n pi, if n is odd. It turns out to be these two are similar, right? These two are similar, even and odd. So we just take that we just combine that, means that bn is just this value, negative 2 over n pi, no matter if n is odd or even. So n can be used for any number, okay, no matter it's odd or even. So finally, we want to collect the answer to write the Fourier series. So this is the Fourier series formula. You can refer this in the math formula book. And then you have to substitute all the obtained values a0, an, and bn. Remember, you can look up your a0 is 3 and your an has value on the odd numbers only, and bn cover both odd and even. So means that you can separate the summation, okay? What I mean is, okay, first ft, a0 is 3, so we substitute 3 here and then plus sign. And then we have summation, this is an, right? But an only works for odd. So in the summation notation here, we are writing for odd number. How to write for odd number? We just need to write like this, 1, 3, 5, and so on. This indicates for odd number only, right? And for bn, you have to put another summation because bn works for both odd and even. So n start from 1 to infinity and write your bn and complete the behind part. So altogether, this is your Fourier series. This is your final answer. Okay, and alternatively, again, you can solve the bn by using tabular method. You have to show all the calculation here, and it's a long solution, and you can try it and you can get the same solution as it is. So that's all for this example. Bye bye. Thank you.